Welcome to EDU World Space.
So the potential energy of the O- of guanine and the OH bond of cytosine is this, and can be represented by the following. So U of the bond between the O and the HO is equal to Coulomb's constant times the charge of oxygen times the charge of hydrogen. So the first two bonds here over the radius or the distance between the nuclei of the two molecules. And now moving on to the second bond here. Let me write this a little bit better so we can understand. I'll just go ahead and just write this as U. So the potential energy of the bonds, as I stated before. And now it's also plus the final bond, which is again Coulomb's constant times the charge of oxygen and times charge of the second oxygen over the radius between the two molecules, which is the radius between the two molecules. So now, since these are all constants and they're the same for the types of molecules, so we can just plug it right into the equation, and we can get the potential, which is equal to 8.99 times 10 to the power 9. And since the Coulomb's constant is the same in both, we can just factor it out. So this is times negative 1.6 times 10 to the negative 19. Negative 19 here. And this is squared plus, sorry, this is actually not squared, but it's times positive 1.6 times 10 to the negative 19. And this is all over the radius of OH, which is equal to 0.18 times 10 to the negative 19. And this is plus negative 1.6 times 10 to the negative 19. And since this time it's the charge of two oxygens, we can just square this. And now this is again over the radius between the nuclei of the two oxygens, which is equal to 0.3 times 10 to the negative 9. Negative 9. And let me write the 9 a little bit better. Here we go. So now if we compute this into a calculator, we're going to get that the potential is equal to negative 51.09 times 10 to the negative 20 joules. So now to find the potential energy of the nitrogen minus of the cytosine and the H positive of the guanine. So let me just make that clear. So this is here. Let's make sure that we know which potentials we're talking about, which potentials of which bond. So this is U NH. Sorry, this is OHO. So now if you look at the potential of the next bond, which is the nitrogen, so which is UNH, and now we can set this equal to, once again, it's the same formula as up here, except we switch out the different variables for these new molecules. So now once again, if we just compute it, so it's 8.99 times 10 to the negative 9, times 10 to the positive 9. And now it's Once again, negative 1.6 times 10 to the negative 19 times 1.6. This is positive 1.6 times 10 to the negative 19. Hold on, let me write this 10 a little bit better. Over 0.19. So this is the radius between the NH bond times 10 to the negative 9. And this is plus. And now this is the potential of the the two nitrogen bonds. So this is, once again, just negative 1.6 times 10 to the negative 19. And since it's two nitrogen bonds, we can just square it. Since the charge is the same, and it's just multiplied by each other. Once again, this is 0.3 times 10 to the negative 9. This is a square. Yeah. So now if you compute this into our calculator and plug all these values straight into our calculator, we're just going to get that this potential is equal to negative 44.4 times 10 to the negative 20 joules. So now finally, to calculate the potential of the last bond, which is U So now this is the potential energy of the O minus of the cytosine and the H plus of the guanine, and plus the potential energy of the O minus of the cytosine and the N minus of the guanine. And so if we set this equal to the same equation as above, I don't need to write it again. So if we just compute it, so once again, Coulomb's constant is constant, so we can factor it out. And since it's there in both equations, 10 to the positive 9. Now it's negative 1.6 times 10 to the negative 19 times 1.6 times 10 to the negative 19 over, and this is the radius between the OH, so this is 0.18 times 10 to the negative 9, and this is plus negative 1.6, and once again we can just square this since the two charges are the same. So if we square this, since the two charges are just being multiplied together, so we can just save time by squaring it. That's the same thing. And now the radius is 0. So this is the NHHN bond. So the radius is 0.2 times 0.29 times 10 to the power of negative 9. And now if we compute this, hold on, this looks a little messy here, so let me write this a little bit better. So this is 8.99. So now if we compute this into our calculator, we're going to get that it's equal to negative 48.33 joules. So now if you just add these all together, so it's the potential, these three potentials added together, we're going to get that the final potential of the guanine and the cytosine bond is equal to negative 1.438 times 10 to the negative 18. And don't forget the units, joules. So this is our final answer, and thank you for listening.